Thanks. And so like with the talk before, if you've got any questions as we go through, please raise your hand. If you're back in that corner, run into the light, maybe wave it, because I'm going blind looking back there. And I may not see you. But otherwise, let's try and keep this as interactive as possible. How many people are familiar with WebPagetest? OK, good. I was hoping I wouldn't have to do it, because I didn't prepare a walkthrough and an example. It was sort of deep dive right into, hey, you want to set up a private instance, this is how you do it. And I was hoping I wasn't going to lose people. I sent out the slides on Twitter maybe 20 minutes ago, if you look on the Velocity Conf, mostly because this screen up here is really hard to read. There's another screen back there. So if you're in the back half of the room, maybe you'll get some off of the TV. But if you also want to follow along with the slides, try not to make it too much of a wall of text. There's a fair number of graphics, but there are some places where there's like configs and stuff like that that might be worthwhile to have the text. And it'll all be on SlideShare for ever or until they're gone. Probably in a couple of months, if history serves correct, the videos will show up on YouTube. Once O'Reilly's done processing them, I'll send those out on Twitter as well. So if you missed something and you can't quite remember what I said and it wasn't in the slides, that'll be available after the conference as well. And pretty much, I'm Pat Meenan on Twitter, so you can find, I usually try and only tweet about performance topics. So if you check out the tweets, that's where you'll find the slides for this, for example. So diving right in, WebPagetest. So the reasons you might want to run a private instance, so there's the public instance, webpagetest.org. Feel free, hit it as much as you want, run as many tests as you want. There's an API as well. If you need an API key, you email me. Although it's fairly limited, you can only run a few pages a day kind of a thing, because it's not a monitoring system. And as Steve mentioned, it's run out of the basement of my house largely, so there are no SLAs. If it goes down in the middle of the night, well, I'll look at it when I wake up in the morning. So that, as well as wanting to run a whole lot of tests, or if you want to test things that are behind your firewall and aren't reachable from the public agents, are a whole bunch of reasons why you'd want to run your own private instance. And if you want control over the results, right now the public instance, the test agents in Dulles I control. There's some that run on VMs, which are the normal Dulles ones. There's Dulles ThinkPad, which is a stack of ThinkPads, which are running on actual hardware with GPU acceleration and all of that. And there's a bunch of physical devices for phones. But the rest of the locations around the world are ponied up by people who sort of barter logo at the bottom of the page in exchange for running a test agent. So you get kind of whatever hardware mix they happen to pony up. So there's no guaranteed consistency. If you test from London and test from Dulles, there's no guarantee that the performance is going to be equitable across the hardware. These are sort of the risks you run with the private instance or the public instance. And you can control all of that when you run a private instance. Architecture-wise, it's pretty much there's the web server, and then there's a whole bunch of agents that connect up into it. And then the agents do the actual testing. They run real browsers on real devices. So like the desktop agent, for example, the only thing that's really supported right now is Windows. And on Windows, it supports IE, Safari, or IE, Chrome, Firefox. And technically, it supports Safari, but it's Safari on Windows, which is like version 5 and no longer supported. So I don't know if you even want to bother testing with it. But it's there just to be aware of it. Chrome on Linux can technically run, although I wouldn't recommend it at this point. Not only do none of your users actually use Chrome on Linux, it's mostly developers and Chrome developers mostly. But it's also the data you get out of it isn't nearly as rich as the data you get out of the Windows agents right now. On mobile, there's the MobiTest agents, which Akamai, and at the time it was Blaze before Akamai bought them, built iOS and Android WebView apps that can run standalone on a phone and run tests and report the data back. They'll test UI WebView. The granularity on the data they get back isn't great, but it was sort of all we could get at the time, and it was really awesome work. And the video, it can usually capture maybe 1 frame a second, and then it has like a 30% impact on the page load, so you kind of want to be really careful doing video on a MobiTest agent, for example. The newest hotness in mobile, I guess, is the Node.js agent. It's a little more complicated. It has phones tethered to a PC, and Android is really best supported right now, but it'll do full waterfalls, all of the details, TCP dumps, timelines, and 60 frame per second video, which is actually a whole lot better than we can even do on desktop. So you get like really granular, awesome videos out of the mobile agents. iOS can run tests. That's actually my focus next quarter is going to be to beef that up. You can't do video on iOS right now, for example. Well, you can, but it requires like HDMI video capture and dedicated PCs and all sorts of other complexity you probably don't want to get into right now. So hopefully iOS will be in much better shape at the end of the year. But Android is really well supported and works really well. So, oh.
The Node.js agent, is it also Windows only, or can it run on other OSs?
So the question was the Node.js agent, if it was also Windows only or if it can run on other OSs. It's actually anything that'll run Node and ADB. So pretty much anything. The ones that are supported best are Linux and Windows. I may have something on this later, but and which one of those works best depends really on the hardware you have at hand and what version of Linux you're running. Older versions of Linux and USB 3 do not get along at all. So if you've got hardware that has USB 3 ports on it, you need to be running a really new Linux kernel, otherwise the devices will fall offline like continuously. Windows in general works really well as far as the USB goes. ADB on both platforms is buggy as hell. It's probably the best way to put it. So there's a bunch of tweaks you have to do. Like on Linux, you need to set processor affinity for ADB so that it sticks to a specific thread, and that'll prevent it from deadlocking more often than not. On Windows, I've got a separate app that'll run as a watchdog, and if ADB hangs, it'll nuke it and let it restart. So there's a couple of things you have to do to improve the reliability, depending on what platform you're on. Theoretically, it should work on Mac as well. I don't know that anyone's tried it, so let us know if you get different experiences back. But in general, so the web server is the central key that everything connects into. Users submit tests. So you go to WebPagetest.org or whatever your private instance is, you fill out whatever you want in the UI, and you hit submit test. That ends up calling runtest.php and does a submission, a form submission, basically. The API, if you look at the RESTful API, also goes to runtest.php. And everything that's documented on the RESTful API page is the UI goes through the API. So if you're getting different behavior when you're using the API than when you use the UI, it's going to be a parameter that you're submitting in there. And if there's something you can do in the UI that you don't see documented for the API, it's probably because I forgot to document it. But it's available through the API because that's how the UI goes. So you just inspect the form on the UI, and that'll tell you what the parameter is to turn that on. But it's important to pay attention to the direction. So in this case, the users are connecting into the web server. So the web server is not doing anything out. And then when a test gets submitted, the server creates a test ID for each test. And generally, if you look at the test IDs, they end up in the URLs for all of your results. They're year, month, day. And then it ends up with a bunch of numbers after that. And for the most part, that first bucket is a hash. And then it's another number that's sort of unique. It's either an incrementing number or a completely random MD5 if it's a private test. So it's not a guessable test ID. And then the tests locally on the server are all stored in a directory tree relative based on that ID. And they're stored in the results folder off of the doc root. You get a year, so there's like 14 for 2014, and then the month, and then a day. And then inside of the day folder, you have the hash creates another directory, and then the number at the end of the test ID ends up as the final directory that the test results for that test get dumped into. And that's mostly so that if you're running a large number of tests, originally we didn't have the hash in the WebPagetest tree structure, and when we got to running more than 30,000 tests a day, ext3 started puking because it didn't like having more than 32,000 files in a directory, or directories in a directory. So that's mostly there just to break it up. And it's scaled. We run several million tests now without having file system problems like that. And then, so an empty directory gets created before the test actually gets run. And then job for that test gets written into a separate directory, which is the work queue for that test location that you submitted. Like if you pick Dulles, under work jobs, all of this is off of doc.root, Dulles, there would get a file that has the test ID dot and then the priority that the test gets run at. And so that is the definitive location where all of the pending tests get written to. But they also go into a in-memory queue that gets written into the temp directory so that things are kept in order. Another sort of historical, when we used to do the testing, we used to just use the directory, but then guaranteeing the order of tests. Turns out people started submitting tests within the same second, and then ordering them by the time created wouldn't work for guaranteeing order, so we have a separate queue that guarantees the order of test execution. And then after all the server's done all of that, it redirects the submission, redirects you as a user to the results page. And then the browser ends up just polling. There's an AJAX, so you're waiting for the test to run. There's a little bit of AJAX that sits on the page, just polling, checking the test status for that test ID. Or if you're using the API, you're querying teststatus.php, asking for the test status of that test that you submitted. And once again, these are all still inbound to the web server. Nothing gets pushed out. The test agents themselves also poll the web server. So all of the connections to web server are inbound, port 80 or 443 if you're using HTTPS. It never pushes anything out to any test agent. So if you're having problems submitting a test and getting it out to the test agents, it's worth noting that the submitting is all done completely isolated within the server. And then the test agents go, hey, do you have work for me? And they poll largely every 15 seconds, although if they complete a test, they ask right away, hey, do you have more work for me? So when they're idle, they'll poll every 15 seconds, and then while they're working, they'll run as fast as they can. Which means there's also up to a 15-second lag or so after you submit a test before it actually gets picked up to be worked on. Then the test agent goes ahead and does what it needs to do, launching the browser. For the most part, the way WebPageTest works is it runs the browser, and then it just records whatever the browser does. And it's just measuring and reporting what the actual browser chose to do. So the performance results you get are going to largely depend on the browser you selected. And then it relies on the browser going out and testing the page that you asked for it. It records everything that it can about what happened. And then it posts everything back to the server. When it sends the results back, it actually does it in a whole bunch of different calls. Everything that the test agents talk to on the server, it's in a subdirectory work. So there's work/getWork to get the work, and work/result_image. It's unfortunate the naming, but it's because we used to only upload images that are screenshots and things like that. But any of the large files, TCP dumps, net dumps, dev tools, screenshots, video frames, all of that kind of stuff, those get uploaded one at a time at the end of the test result to this result image. And then after all of the component pieces have been uploaded, it calls work/work_done. And it says, OK, I'm done with that test run. Here's the results. And that also includes a zip file that has just a breakdown of the requests and the page stats, for example. That doesn't necessarily mean the entire job was done. There's a separate flag that it sets. So if you're running 10 runs, for example, it'll actually call work done 10 times, one for each run. And then on the last one, it'll say, hey, the whole test is complete. And then the client browser that was polling the server for the results, it gets, hey, the page is finally done, and it redirects to the actual result page with the waterfall. So as far as the server goes, what it takes to actually run this, originally, WebPageTest was hosted on DreamHost, so it was sort of constrained, and the goal was to make it as easy for people to set up as you can. So it has almost no requirements. All it needs is something that can run PHP. Linux tends to work best. It doesn't have any databases or anything else. Everything is local file system on the server. But Windows works fine. You can run a Windows test agent and the web server all in one PC if you want to have like a really small environment and you want to test things out. That's how I do most of my dev. The production server runs on Linux. It just scales a whole lot better. And as far as the install goes, you pretty much just copy the distribution, the www directory from the distribution up to the server, and then point the server. So if you're Apache, there's an htaccess included with the distro that does the rewrites for friendly URLs is really all the htaccess does. And it'll work without it. And there's also an Nginx conf that you can include in your Nginx config that has all of the rewrite commands in it. And then there's also, and I'll actually walk through this in a second, there's a /install page that does a bunch of sanity checks for your server config to make sure that all of the dependencies, all of the modules, and the permissions on the file system are appropriate so that it'll run. And as far as the dependencies go, there's mostly, so like the biggest ones that you end up running into on a default config at least, so at the end of the test, it uploads all of the results one at a time. You want to make sure that your PHP and Apache configs or your server configs allow posts to be big enough that you can actually get your screenshots and TCP dumps back to the server. So if you're missing screenshot files, that's one of the common occurrences is your post set, I think it defaults to like 2 megs. And sometimes they'll come in, sometimes they won't. And as far as PHP dependencies, there's just a handful of them. It needs GD, which is an image drawing library to be able to draw the waterfalls or to do the thumbnails. So if you it'll run tests, but you won't see any waterfalls. It's fairly common that you just don't have GD installed. But if you go through the install page and just knock out everything that it says, hey, this is missing, you'll be in pretty good shape. So I have a completely naked webpagetest.patrickmeenan.com is a server I just set up. It's just Nginx pointing to an empty directory right now. Yeah, nothing there. And this is fun. Ooh, internet's working. So on the left side, so I use WinSCP a lot for doing my file copies and stuff. But on the left is just so this is the distribution for the latest WebPageTest private instance release. It's 2.15. Inside there's directories for the agents. There's the mobile agent, and then there's the www directory. And pretty much just copy all of that up to the server directory that it's serving the files from. And apparently we'll come back and touch on that in a minute. Oh, there we go. Just while we're doing that, I'm going to open up a SSH because I know the first thing that's going to be very wrong, file permissions are one of the things that are the most problematic usually whenever you're setting it up, especially on a non-Windows box, is your web server is running as a user that is usually not the same user that you're logging in with. So all of the files that you just uploaded are uploaded, but the server has no permission, so it can read them. But when we go, yeah, so I mean, it uploaded. We've got a fully operational instance, and that's pretty much all there is to it. However, down here in the file system checks, so this is what the install page looks like, and it basically gives you a green check mark, everything looks okay, a yellow exclamation. It's like, well, it's not really needed, but if you want all of the functionality of the private instance, this module is missing. It's kind of optional config stuff. And then big red X's mean, yeah, you need to fix something. And in this case, it's all of the file system permissions because they were all uploaded with my user account, which is different from the web server account. So, whoop. I can make the font bigger, maybe. If that's not readable, all I did was I changed to the web directory where it's serving all the files from. And I'm just going to change the owner, chown, to www-data, which is the standard Apache and Nginx user for running the web server. Star, and I forgot to put a -r to do it recursively. Oop, and I forgot to do it as sudo. And just to make sure there's no also going to chmod it. I think I'm doing 755, but that's less needed. That's mostly so when I go up later and want to edit files, I can do that without having to log in as the user or do it through sudo. So all of the file system stuff is green now, so we should be in good shape for the most part. If you notice down at the bottom, there's no test locations configured or no agents connecting, and that's because we haven't configured those yet. And we'll get to the test agent config next. There we go. So it's probably a little hard to read, but as far as the Nginx config goes, this is nothing special to WebPagetest. It's except for the very last line, but all it's saying is all of the .php files pass it through to fast CGI. However, you've integrated PHP. It's pretty much a stock PHP web server. The very last include is just including the Nginx conf from the WebPagetest install. And that does all the rewrites for the friendly URLs. And this is what the install page looks like. In this case, I got all green checks, so I'm not doing quite as good as my screenshot. As far as actually configuring the server instance, there's just, so everything you need to touch is in the settings directory. And there's only a couple of files that really matter in there. Settings.ini is where the main server settings go. And that's where you'll put like what your contact information is, if people need to contact you. The maximum number of runs you're going to let people run. So on the public instance, I cap it to 9 runs. On some private instances, we have that set as high as 500. For example, if people want to do like really huge tests. The default quality you want to use for JPEG compression for screenshots. If you have a show slow instance, you can integrate it in there. Basically, just give it the URL to where the show slow instance is, and it'll send beacons off to slow show as tests complete. If you're doing test archiving, and we'll get on that later, that's where you would configure it. Also, if you're sort of logging the test results as they come in, you would configure it in the settings.ini. And then locations.ini is sort of the main beast that you're going to have to wrestle with, and it's probably the single place where I get most of the issues where people are setting up private instances where they have problems sort of putting together a locations.ini that represents, and that's where you define what all the test locations are and what the agents connecting in look like. And so basically, on the main WebPagetest site, you'll have 2 drop-down areas that are mostly controlled by that. The test location is sort of the global, in the case of the public instance, it's Dulles, Virginia, London, Europe. It's the physical location where the test machines run. In case of private instances, we also have cases where it's like Atlanta Internet, Atlanta Corporate LAN, for example, and those will be completely separate test locations. But those don't necessarily map down to the individual location IDs. A combination of test location and the browser. So each test location has a certain set of browsers that are supported, and those can actually be supported from multiple different location IDs as far as WebPagetest is concerned. So like for Dulles, Virginia, we have the desktop Chrome agents, or desktop Chrome, IE, Firefox, a bunch of different versions of IE, as well as the mobile agents, all reporting into the same test location grouping. And the browser dropdown just has all of the different browsers listed, even though there's multiple different agent configs talking into those. And the way that works out is, so the locations.ini, right up at the top, it has an ordered list of what your locations are. That ordered list is of the groupings that you want to show up in the location dropdown. So like Dulles, London, the high-level groupings that you want to advertise to the users in the order that you want them displayed in the UI, and which one you want selected by default. And then each one of those groupings points to a collection of actual location IDs. So these are the, like NYC and NYC Mobile in this case. Those are the actual location IDs that'll get used in the test agents, as well as when people submit API tests, for example. You won't submit it to group 1, you'll submit it to NYC as the location ID. And then that's just a list in order of how you want the browsers to be displayed in the browser dropdown. The label there is what shows up in the actual test location dropdown. So whatever text you put there, it doesn't go anywhere else. It's only used in the location. And what I usually do is I put the physical location and then list the browsers that are available so people sort of know without having to click and go through the browser list what's available from that test location. And then each one of those location IDs, those are the ones that actually show up in the browser list, and this is where you define what the test agent connecting in is going to be configured for. And there you provide the list of browsers, and it's browser equals, not browsers, but browser equals, and then the list of browsers available for that test location. You can have, so depending on what your test agent is, if it's the desktop agents, and it's WPT driver, they're sort of two desktop agents. You can have the Chrome, Firefox, as well as the IE version, or you can split those up and run them separately. The mobile, there's sort of special hard-coded stuff on the mobile agent side, where usually you'll just have one browser ID in the mobile agent list for the version of Chrome that's running. It knows how to recognize if there's like a dash Chrome and dash Chrome beta. You can run both Chrome and Chrome beta from the Play Store on the same devices, and the agent will know which APK to run or which browser to launch if you have a comma-separated list. You can put anything you want in front of the dash. So in this case, they're running on Motorola Gs, and so we say Motorola G Chrome, and that's so you can have like Motorola Gs, Nexus 5s, all sorts of different devices, all reporting into the same top-level group, but they would be in different locations. So this could be like NYC Moto G, and then there would be a separate NYC Nexus 5, and they'll all show up in the same list of browsers. So you need to make sure everything in the same group, you don't have collisions between browser names. Otherwise, well, I don't know what will happen. It will be completely indeterministic, and things will look bad. So you can't just say like Chrome and Chrome beta in the mobile one. Otherwise, when you have the Nexus 5 location, it won't be able to tell which one it belongs to, for example. And those browsers listed, when you aggregate all of the locations in the same group, is what shows up in the browser dropdown for the users. And it's really important. It's the UI, as far as it's concerned, that location, every agent that connects to the NYC location supports all of the browsers in the list, Chrome, Firefox, and IE11. Because when the agent asks for work, it just asks for it based on the ID, and the job that's given to it tells it what the browser is going to run. So if the agent can't support one of the browsers, it's going to report an error back and not give any test results. However, each agent can pull from multiple test locations simultaneously. So for the main reason we implemented this was, in the case, IE is the only one that's painful, in that a given install of Windows can only run one version of IE at a time. Odds are you want to test against more than one version of IE. However, let's say you've got half of your machines running IE10, half of them running IE11. It would be a real shame if you could only test Chrome or Firefox on half of your machines. So you can install Chrome and Firefox on all of the machines, and have all of the machines connecting to the NYC location, which is Chrome and Firefox. And then you can also have half of the agents configured, so you do it with comma separated in the agent side. You do NYC, comma, NYC IE10. So this agent will pull for both the New York City, which is Chrome and Firefox, as well as the IE10 specific tests. And the other half would be configured for NYC, comma, NYC IE11, and it'll pull for the other half of the IE tests. And that way you can run Chrome on twice as many machines as you could with IE, and you get sort of all of your capacity there. And that's what we do on the public instance, for example. All of the test machines will run Chrome and Firefox, including the ones that are configured for IE 8, 9, 10, and 11. And then just those that are configured, I think we have like 2 machines each for IE 10 and 11, 4 or 6 for IE 8, and 19 for IE 9, or some combination like that. Adding up to 19 total for IE 9, however, 29 machines available for testing Chrome and Firefox. So we can mix and match the IE depending on what we want to test and not impact our Chrome and Firefox capacity. On the settings.ini, you can also add a map equals 1 if you want to display there's a select from map icon, depending on what your global footprint looks like when you're doing the test instance. If you want to be able to provide them the sort of the push pin selection UI. In that case, when you have the groupings and when you define the locations, you need to put a latitude and longitude for each one of the locations for it to show up in the map. And that would go into locations.ini. If there are no lat and long for a given location, it just won't show up in the map. And if the lat and long are exactly the same, like if you have a corp LAN and a public internet in the same location, well, the pins are going to be right on top of each other. So there's also a drop down in the map where they can select. You can also group if you've got enough test locations where it makes sense. On the public instance, we group them by continent, basically. And you can define the group in the locations.ini as well. So it sort of builds up. There's a bunch more options. They're not all necessary for the bare config. The other thing to watch out for is if you have a test agent that traffic shaping is not configured for or supported. You couldn't install DummyNet for whatever reason on the test agent. You need to put a connectivity line in the location-specific definition for that test agent. That's what will show up in the UI. Whatever string you put in there, like in this case it says Google Fiber, the connection drop-down for the users will say Google Fiber, and they won't be able to change it. And if you don't define that and DummyNet's not configured, you run a test, it'll try and configure DummyNet, and it'll fail, and it'll report back and say, test completed, but no results available, IPFW config failed, or something like that. So you can run without traffic shaping. You just need to define it on the server side what the connectivity is. That also matters for mobile if you're not doing traffic shaping, which is more often the case than not right now, because traffic shaping on mobile is kind of a pain in the butt. We'll get to that in a second. You just put in config for whatever connectivity you have defined. And that doesn't actually control anything. It's just what the user sees as far as the UI is concerned. And the other thing you'll probably want to be aware of, you can define an API or a key. It's just a shared string. It doesn't really matter what you put in there. It's a secret that you need to configure on both the agent and the server in case you're worried about people pushing results to a server that aren't from the agent. Don't know why anyone would want to, but it gives you a little extra protection, especially if you're running your web server out on the public internet and not inside of your firewall. It just gives you a little extra protection against people uploading files and stuff to your server. The other thing you can configure in the ini file is the expected number of test agents for a given location. There's a cron job that'll run I guess it depends on how often you configure it, but I have it set up to run every hour. And if the number of agents connected for that location doesn't match the configured number, you'll get an email. By default, you'll just get an email if there are no agents connecting in for that location, but you can also do it for if the expected number of agents drops down below what you're expecting. And this happens more often than you'd like, especially in the case of mobile. Devices kind of fall off here and there and need to be given a swift kick or a reboot or something like that, on the order of every couple of days. And you can also put in a notify list. By default, it'll take the contact information in settings.ini, and it'll email that person as the site admin. But for a given location, if you also want to email like a hands and eyes or a support team or something like that, you can put the notification list in there. And if the location isn't quite ready for public consumption, you can add a hidden flag. And that's if you're testing things out, getting things set up, and you want to be able to use it in the UI, but you don't want normal users to see it. It's not terribly well protected. If you go to the main page and add a hidden equals 1 query param, you'll see all the hidden locations as well, but it lets you test things out end to end before making a location available to your end users. And yes, if you do this on the public web page test, you'll also see the hidden locations, which are largely the locations that are no longer working or are down right now. It will also, if the test agents stop reporting in for a given location and haven't connected in the last hour, it will hide them automatically in addition to sending the emails out. So if a location disappears on you for some reason, odds are it's because the test agent stopped connecting. Everyone still with me? Everyone's still awake? Good. As far as configuring the test agents, on Windows, there's a fairly long list of stuff you need to do to get things ready. The most important things are getting it to log in straight to the desktop and launch the agent as part of auto login. and to disable anything that will turn off your desktop. So screensavers, power management for the screen, anything that'll force auto log out the user after a certain period of time all need to be turned off. The main reason for that is screenshots and video capture record the screen that's visible, and if there is no desktop, the browsers will not paint anything, so you will start getting black screenshots. When you RDP in to a test agent to work on it or to tweak something, if you disconnect, it will lock the desktop and you will start getting black screenshots. So one of the important things to do is every time you connect to a test agent, you need to reboot after you're done to get it to auto log in by itself to an unlocked desktop. That's unfortunately one of the most common things that happen. If you want to do traffic shaping, you also need to install DummyNet. It's all included with the distribution. There's a list of steps required to install it, but it's fairly straightforward. But largely just copy the agent files over to a directory. Once the machine's configured, you just run it, and then you install all the browsers you want to do for testing. I have a sample ini in a second, but the one browser that you probably don't want to install by hand is Firefox, mostly because it won't auto-update itself. Firefox auto-updates work in idle time when the browser's open and not doing anything, which in the case of WebPagetest is never, because the agent launches the browser, runs the test, closes it. So it never auto-updates itself. Chrome has a separate service that auto-updates. So if you install Chrome manually, Chrome Canary manually, it will keep updating itself on its own. Firefox usually needs to update, and WebPagetest has a built-in mechanism where it'll automatically install updates for any given browser. As part of the ini config, it will also install that browser on first startup. So it'll install the latest version of Firefox, and then anytime a new release is pushed out, it'll auto-update it from the URL that you put into the config. And this is going to be an eye chart. There we go. So this is what the client config looks like. The main things you need to do, give it a location on where it's connecting to. If it's on the same server, 127.0.0.1 works fine. In the case of mine, I give it webpagetest.patrickmeenan.com to connect to the instance that we just set up. You give it the location, and this is the location ID of the location within the group, so the ones that we were talking about earlier that have the browser-specific configs. Right below the location, there's a browser equals. You can mostly ignore that. That's just the default browser if the server didn't specify one for running a test. And these days, the server should always specify one. So that should never come into play. Time limit, how long you want it to be able to run a test before it considers it a timeout and force quits the browser. On the public instance, I think we have this capped at 60 seconds. You might want to allow longer if you have slower pages internally. Maybe you'd be a little more generous with your clients and let them run for 2 minutes or something like that before it terminates the browser and calls it a timeout. There's, right below those, there's support software for Flash, Silverlight, I think, yeah, Flash and Silverlight. You can comment that out if you want, or if you want the agents to automatically update their Flash versions. You can either set up your own URL and manage your own versions of Flash, or you can just point it to the public WebPagetest one. And every month or so, I update the version of Flash that's there, and it auto-updates it so that the agents have the latest version of Flash as well. And then you get into, this is where you define the browsers that are present on the local machine. And remember, these need to match, or at least have everything in here that's available on the server list for the browsers that that location supports. You mostly don't want to change the command lines. The only thing you want to check for Chrome, for example, whoa, I clicked on something. For Chrome, for example, for all of them, you want to check and make sure the exe is actually pointing to the right location. You can usually just give it a program file substitution, but if you want to point to an exact path, program files x86 versus not x86, just make sure that directory is accurate. Otherwise, you might get a couldn't launch browser error when you try submitting tests. The options, there are some options in here that you do not want to change, like load extension. If you get rid of that, it won't run the tests because it won't load the WebPagetest extension that talks to the agents. The user data dir, also leave that unless you're doing very special things. That cleans the profile before every time it launches Chrome. And if you change that directory, you can give it a different directory if you want to run without clean cache, for example, if you want to run some test agents that keep accumulating browser state as you go. And the final one, no proxy server, is probably the only one that you may or may not want to tweak. By default, I turn off proxy servers because you don't want to test with proxies. They completely muck up how browsers behave. But if you do actually want to test with proxy, you can change that. You can also specify it on a per test basis. And then, so Chrome and Firefox all have the same thing. And then there's an installer line. And this is where Firefox, for example, if you want to install the latest version of Firefox automatically, you'd point it to either your own copy of this DAT file or just point it to the public one and you'll get whatever the latest version. Usually within a couple of days of Firefox releasing their latest version, I push the latest one up there. I do check and make sure the agents actually work with it, although there's a chance if you're not tracking with the agent updates, there's a chance you'll get a newer version of Firefox than what the agents that you're running support. For the most part, they're good at being backward compatible. And Safari and IE, all you point to are the exe. There's nothing else to point to, nothing else to configure in there. And where things really get interesting and fun, and this is, I'll spin one up in a second, so we'll have a live test agent. EC2. So you can have a global testing footprint without having to actually deploy any hardware of your own. There are AMIs available for Windows for all of the browsers, IE 8 up to 11. All of them have Chrome, Firefox, and Safari on them as well. And you don't actually touch the EC2 instance at all. You don't log into it. You don't do anything. You pass a couple of config parameters through the user data when you're spinning up the instance, and they know how to pull that config data and automatically connect up to your server and install all the latest browsers and stuff like that. So in this case, you just pass the WebPagetest server and the location ID that it's connecting to. And spin them up and kill them as you need. For example, on the public instance, we do a fair number of benchmark tests weekly. So every Saturday morning, I think we spin up 40 EC2 instances, run a whole bunch of tests, spot instances, they're dirt cheap, and then we shut them down when the testing's done. And so we only pay for it while we're running the benchmark weekly, and then we're done with them. I do recommend you don't use small instances. Definitely don't use micro instances if you want consistent results. Anything medium or better, I don't know why you'd really want to use better because you don't get any faster results. So medium's sort of your sweet spot on test instance size from EC2. And I know C1 is outdated. They have C3 medium and like T2 medium or something like that. C1 medium has the best spot prices, so you can still get them, and I highly recommend if you can. The legacy ones, I think they're like 1 cent a minute or 1 cent an hour or something ridiculously cheap. And you just put in, either through the API, there's a way to do user data, or in the UI, this is actually a slightly old UI. We'll see the new one in a second. You just paste in the user data when you're launching the instance, and then usually within 5 minutes or so, you'll have a test location connecting into your server. And this is the current EC2 map. We'll see if I think Africa is like the only continent missing at this point. They've got sort of really sweet South America, North America, Asia, even Australia test locations. So if you've got a global footprint you need to do testing on, it's really an easy way to do it. And let's see. Go ahead and kick off an EC2 instance, and then I'll talk a little bit about mobile agents while it's spinning up. So it's a little easier from my account because I own all of the AMIs. So the only extra step you'd have to do is you'd have to search for the AMI ID for the one that you're trying to launch. And that's the one we want to use. And zoomed in UI issues. In this case, we'll use an M3 medium. And this is where the user, so under advanced details is where the user data is buried right now. And you'll do it as text. I just need to, I'm going to cheat a little and get the user data I have already defined, just to make sure I don't typo it. Yep. Mostly because I have a key set up on the server, which looks like it's 5.9, so it's not all that secret of a key. Come on. There we go. Yes, you're open to the world. Okay. As far as the firewall goes on the agents, they all connect outbound, so you don't need any inbound ports open. I think I just left the default, which opens RDP up to the world or something like that, mostly because I don't care, because I don't need to connect into it. But when you launch it, just use the default security group with no connectivity in, because they all connect outbound to the server. Okay, instance is launching. We will get back to that in a second.